This is post hoc analysis in SPSS. We've conducted our omnibus ANOVA tests, and we found there was statistically significant differences between groups. P is less than or equal to 0.05. So now we're on to next steps. Where is that difference located? First, starting off with our data, we're going to take the data, which is grades and post-self-efficacy. I'm going to paste it into SPS. I'm going to label the variables first. So variable 1 will be grade. I'm doing it a little differently this time. I always do it the other place. And then we'll have self-efficacy. If you put it in the var, you can't have any spaces in it. I'm going to make a box and whisker plot where grade is the category, the independent variable, and the variable is self-efficacy. All right, so now we can see what we're actually looking at. We can see we've got this. We've got a couple of outliers. I'm not going to worry about those right now. We're just using this for the purpose of saying, is there a pattern I can see? Well, it sure looks like this is lower than this is lower than this. The question is that true or not? So let's go through and do the analysis. Now, normally you would do your own descriptive statistics. I'm going to skip that part for today, because we've done that enough times. We're going to go to the general linear model, select univariate, where the fixed factor is grade, and the dependent variable is self-efficacy. And we're going to make some choices too. So we're going to do some options first, descriptives, effect, homogeneity tests, and then we're going to do some post hoc. Now, there's lots of ones you can pick. We're going to move grade over for post hoc, and we're going to select the 2 key, the honestly significant difference 2 key. There are lots to choose from. That one is generally the one you want to use. We'll run that statistic and get the results. So here we can see 4.7, 5.0, 5.6. We look for error variances, Levine's test for homogeneity of variance. We can see there's significance here. So we know that there is no statistically significant difference between error variances, meaning the curves look the same shape. Great. We move on. Then we have the test between subjects. Here we look at grade. Hopefully that will disappear on us. We can see there is significance. P is less than 0.05, so we know there's some significant difference between these scores. Now the question is, where do those differences exist? There are 2 tables that come out for post hoc when you click the post hoc test, and you get the multiple comparisons test and you get the homogeneous subsets. I'm kind of partial to the homogeneous subsets myself, but there are 2 ways you can read this. So here's grade 9 compared to grade 10, and we can see the mean difference. There's no significant difference here. Here's grade 9 compared to grade 11, 0.026. There is a significant difference. So we know that 9 and 11 are different from each other, but 9 is not different from 10. So if we go up here, we can say 9 is 4.7, 11 is 5.7. 5.7 is significantly higher than 4.7. So the 11th grade students are showing higher self-efficacy than the 9th grade students. And then we can look at the second part. 9 and 10, we've already compared that. That's just reverse order. 10 versus 11, there's no significant difference. 0.111 or 1.2. So that's all the comparisons, because we've already done 9 and 11. That was here backwards, and 11 and 10 backwards. So the only significant difference is between 9 and 11. The others are statistically similar. The homogeneous subsets kind of put them together the same way too. So the way this looks, you can see these 2 are similar, and these 2 are similar, therefore making these 2 different from one another. So the better values are generally here in the multiple comparisons, gives you the significant levels for the individual comparisons. And then the self-efficacy sort of spells it out in a visual representation in the homogeneous subsets. And the homogeneous subsets look a little different in terms of the visual representation. You can see what doesn't line up. Check out the next video where I compare the differences of having statistically significant differences in the omnibus, like this one, when compared to statistically similar differences in the omnibus.